Simple interest is a quick way to estimate how something is affected by interest in only the short term. Many things do not work follow simple interest. They actually follow a more complicated formula, but simple interest is very simple to calculate. That's why it's called simple interest. Now, a formula is a mathematical statement with variables, and it shows some kind of relationship between quantities. Formulas are probably one of the most useful things that mathematics creates for different situations. Engineering, statistics, lots of different fields have formulas. So interest equals P times R times T. P is the principal or the starting amount. R is the interest rate. And of course, you're going to write it as a decimal number, not a percent. And T will be time in years. That's going to be important. So if $200 was borrowed at 8% interest over 4 months, how much interest would be paid? And what is the total paid? So this is our principal, how much we borrow. This is our interest rate of 0.08. And our time is not 4, right? This is 4 months. Time is in years. In other words, time is going to be 4 over 12, it's 12 months in a year, or 1/3. So our simple interest is going to be P times R times T. 5.33, and then it's a dollar amount, so it's going to just stop there. So $5.33 is interest. What's the total paid? Well, we're going to pay back what we borrowed, and we're going to pay interest. So total, it's going to be 200 plus 5.33, or 205.33 cents. That's going to be the total paid. Now, if a car loan costs $14,000 with a 3% interest rate and a payoff period of 10 years, how much total money is paid? So total money is paid. And then if it's paid off 6 years earlier, how much money is estimated to be saved with this formula? So first off, our interest is going to be, this is the principal. This is the interest rate. And it's paid off in 10 years' time. So the interest is going to be $4,200. And of course, we're going to pay off the entire principal as well as the interest. So we're going to have 14,000 plus 4,200 equals $18,200 is paid in total. Now, what if we were to pay it off in only 4 years, right? 6 years earlier means 4 years in total. Then our interest would be 14,000 times same interest rate, but now times by 4 instead of by 10. And that gives me 1680. We're still going to have to pay off the principal, right? That's not going to change. What does change is how much interest we pay. So how much money is saved? Well, the interest was 4,200 in this case, and the interest we pay now is 1680. So if we subtract them, that's how much is going to be saved. 4,200 minus 1680 is just about $2,500 is saved. So it definitely pays to pay off the loan earlier. Now, if $5,000 is invested at 8% per year for 6 years, how much interest is earned and how much is in the account in total? So $5,000 is our principal. So our interest is going to be the principal times the interest rate, which is going to be 0.08. And 6 years is the investment time. Putting that in a calculator, I get 2,400. That's how much interest is earned. And so how much is in the account in total is going to be our starting amount. That's still going to be there, right? And then our interest is going to be added on to that. In other words, $7,400. So pretty much the $2,400 is just free money. It's not, we didn't have to do anything for it. It just became there because of interest. Now, typically, how interest works in the real world is going to be with a compounding interest formula. And this formula is a simplified form of that. It's only compounded once per year, which it tends to be compounded maybe every month. So that would actually change the formula, or maybe every day. Could be twice a year, things like that. But here we're just compounding once per year, which is a more accurate formula to what you'd expect. So what's the difference in the amounts and the accounts between these two formulas for this situation here? Well, now our principal, we're going to have our principal. This is going to be our interest. So this formula actually finds the full amount in the account. So the full amount is going to be the principal times 1 plus the interest rate to the power of 6. So we can just plug it into a calculator. Of course, order of operations says we're going to have to do this part first. So we could simplify it that way if you wanted to. 1.08 to the power of 6. And we do 1.08 to the power of 6, giving us 1.58, and then it continues on. I'm just going to multiply that by 5,000, and that gives me 7934.37. Again, this is a dollar amount, so we're going to round to two places. Previously, we had 7,400. Here we have 7,900, just about. The difference is going to be $534.37. So not the small amount of money. That's actually what you're going to end up seeing. However, the biggest difference happens between simple interest and the actual formula that you would use is in the long term. So let's use the same principles, right? $5,000 at 8% interest per year for instead of 6 years, we're going to do for 40 years. So simple interest gives us 5,000 times 8% times 40, or $16,000. And that's, of course, added on to the 5,000 we start with, giving us a total of $21,000 after 40 years. Using this formula, it's going to be 5,000 times 1 plus 0.08 to the power of 40. Here we get $108,622.61. Almost 5 times, well, above 5 times the amount that simple interest showed us. So compounding interest is much more powerful in the long term, and simple interest does not account for compounding interest. That's why retirement is such a huge deal about compounding interest, that you want to do it as long as possible, because that gives you the most effective compounding interest.